Let's learn about serial communication, which is essential as a means of communication in hardware system configuration. In this lecture, we will look at the types of serial communication applied in the embedded field, basic concepts related to serial communication, and basic hardware applications of UART, RS-232, and RS-485. Let's take a look at the types of serial communication methods in embedded systems. In addition to the internal computation core, the MCU has several UART ports, standard serial communication ports such as I2C and SPI for communication with external devices. Most of these communication ports adopt serial communication standards because, in situations where the number of GPIO ports on the MCU port is limited, controlling devices in a parallel communication manner requires multiple ports, which limits system expandability. For example, even if only one 8-bit or 16-bit memory is interfaced, 8 or 16 ports must be used, which may result in a lack of ports for connecting other devices. USB to serial communication. Unlike the PCs of the past, most recent PCs do not have serial or parallel ports. Therefore, in order to communicate with the MCU of the embedded system, a USB to serial device or IC that converts the USB signal to serial must be applied. Therefore, dedicated ICs such as FT232, CP2102, and CH340, which are USB to serial conversion components, are applied to perform serial monitoring or firmware upgrades. In other words, the USB to serial conversion IC converts the USB D+ and D- signals to serial data, TX and RX. UART is a method of communicating by directly connecting to the serial pin of the MCU itself. It is the most basic communication method of serial communication used by connecting to Bluetooth or GPS modules or various sensors that support UART, that is, TTL-level serial communication. It is mostly structured to be connected in a pattern on the PCB board, and only covers short-distance communication of less than 2 meters. MAX232, a serial to RS-232 converter, is a method that was developed to supplement the distance of less than 2 meters, which is the TTL-level MCU's own serial communication, UART method, and is a transceiver IC for applying RS-232 communication guaranteed up to 15 meters. The MCU's TTL-level serial signal is converted into a high-level amplitude signal of approximately plus or minus 12 volts through the serial to RS-232 conversion IC, MAX232, and is transmitted to a remote RS-232 device or terminal for communication. It is a point-to-point or one-to-one communication method, and can control devices that support RS-232 communication, such as POS terminals. MAX485, a serial to RS-485 converter, is a method for communicating over a longer distance, since RS-232 communication is less than 15 meters, up to 1.2 kilometers. The TTL-level serial signal on the MCU side passes through the serial to 485 converter MAX485 and is converted into a differential signal of the RS485 communication standard, so that communication can be made with a remote 485 device. RS485 is a bus-style network communication structure, and parallel connection with multiple 485 devices is possible. I2C is an abbreviation for Inter-Integrated Circuit Communication, and has a bus communication structure that is connected in parallel with I2C supporting devices or elements via 2 lines, the data line SDA and the clock line SCL. It is a structure in which one master and multiple slaves are connected, with the MCU being the master, and multiple I2C supporting devices being connected to the 2 communication lines SDA and SCL. SPI, or Serial Peripheral Interface, is a method for communicating with MCUs and SPI-supported sensors or SD cards. SPI communication requires 4 pins, MOSI and MISO for transmission and reception, SCLK for clock, and CS for device selection. Similar to the I2C, it has a structure in which one master and multiple slaves are connected, with the MCU being the master and multiple SPI slave devices being connected with 4 communication lines. The chip selector, CS for device selection, is also called the slave selector, SS. Since data transmission and reception are separate, it is faster than the I2C. In summary, most embedded MCUs support multiple UARTs, or serial ports, for communication with external devices or equipment. USB to serial is used for programming or serial monitoring purposes between a PC and an MCU that does not support serial ports. RS-232 and 485 are standard communication standards for serial communication with devices or equipment over relatively long distances of several meters or more. I2C and SPI are used for communication between an MCU and multiple sensors or SD cards and other devices on a single board PCB. In MCU, the term USART, which has a more comprehensive meaning, is used instead of the term UART. Let's learn about serial communication and parallel communication, which are some of the basic concepts of communication. Serial communication refers to a method of transmitting bits between devices through a single communication line, while parallel communication refers to a method of transmitting multiple bits simultaneously, such as 8 bits or 16 bits. The main characteristics of serial communication and parallel communication are that the serial method is advantageous for long-distance communication because it uses only 1 or 2 cables, while the parallel method is suitable for high-capacity, high-speed communication over short distances within a device that simultaneously sends and receives a lot of data. The simple serial method can be implemented at a lower cost than the parallel method. And examples of serial communication include communication between equipment in industrial sites such as RS-232 or 485, or when connecting multiple devices within an MCU board. I2C or SPI communication is applied, and parallel communication is applied for communication with HDDs or RAMs within a computer that require high-capacity, high-speed communication. Let's learn about synchronous and asynchronous transmission. Synchronous transmission is a method of sending data together with a synchronous clock to synchronize timing between the transmitter and receiver, while asynchronous transmission is a method of sending only data without a clock line. Therefore, synchronous communication can send data synchronization clock and data continuously, which can increase processing speed and enable high-speed transmission. Asynchronous communication sends only data, so start bits and stop bits are added to the beginning and end of the transmitted data so that the receiver can know where the valid information begins. In general, in this asynchronous transmission, the size of the data sent at one time is sent as a character, that is, 1 character at a time. And the transmitting and receiving parties pre-stipulate the communication protocol, such as the communication speed and data format. I2C and SPI are synchronous communication methods because they have a clock line, while UART, RS-232, and RS-485 are asynchronous communication methods. In this way, the distinction between synchronous and asynchronous communication can be judged by the presence or absence of a clock line. Since fewer communication lines are advantageous for long-distance communication, RS-232 and RS-485 adopt an asynchronous communication method. Classified by transmission direction, there are 3 types: simplex, which only transmits in one direction; half-duplex, which uses one channel to alternate between sending and receiving; and full duplex, which uses 2 channels to simultaneously send and receive. Simplex, a one-way transmission method, refers to a method in which transmission is only in one direction from the broadcaster to the receiver, such as TV or radio broadcasting. Half-duplex, which selectively transmits and receives on a single channel, is a method of communication that uses a dedicated switch to select when to speak and when to listen, like a walkie-talkie. It has the advantage of being able to easily secure multiple transmission and reception channels because it has a structure that transmits and receives on a single communication line, but has the disadvantage of being slow. In other words, it requires a process of following the procedure between transmission and reception, such as waiting for the other party to speak and then speaking. Full duplex is a two-way communication method that allows you to talk and listen to the other party at the same time by using two separate channels, that is, a transmission line and a reception line. It is a communication method for telephones or mobile phones. This full duplex has a disadvantage in securing one more communication channel compared to half duplex, which uses only one channel. It is fast, but it requires securing additional communication lines. Let's learn about various network configuration methods or topologies. Point-to-point means a one-to-one configuration method between devices, and cases such as RS-232 apply this point-to-point method. The bus method is a method in which multiple devices share a transmission path, and can be viewed as a multi-drop method. RS-485, Automotive CAN communication, I2C, and SPI communication use this method, and it is the most commonly applied network configuration method in MCU-based embedded systems. In addition to these, there are tree, star, ring, and mesh methods. The star method is a method in which multiple devices are connected to a single device, such as a hub or root. And the mesh method is a method for very wide communication coverage by connecting like a net, and is applied in building automation, the Internet of Things, etc. Let's look at the most common serial communications based on MCUs, UART, RS-232, and RS-485. UART, Universal Asynchronous Receiver Transmit, is an asynchronous communication method, and is a method of asynchronous communication by directly connecting to the other device with a standard TTL or CMOS level potential. It refers to the case where the main MCU and the MCU built into the device or sensor directly communicate serially. Here, if the voltage level of the two interconnected MCUs is 5 volts, it is called TTL, and if it is 3.3 volts or lower, it is called CMOS. It communicates at a general signal voltage level of 5 volts or less, so communication is possible up to about 2 meters. It is suitable for communication between boards, such as within a system board, on a single board PCB, or connected with a short connector. A Bluetooth module, sensor, or device that supports UART is structured to be directly connected to the UART pin of the MCU, and this UART, that is, the serial port, consists of TX and RX, and in order to communicate between the upper side, the sending side TX and the receiving side RX must be connected, and the sending side RX must be connected to the receiving side TX. Of course, the ground line, which is the reference, must also be connected. Since there is no clock line and only data is sent and received, it can be seen that it is a full duplex asynchronous communication. As mentioned above, UART is a communication method applied on the board within the system, and RS-232 has the same basic communication protocol as UART, but it is a standard communication specification that came out to secure the communication distance with a maximum of 15 meters. In order to secure the communication distance, a dedicated transceiver, MAX232IC, is configured on both sides, and the signal voltage within the communication section with the remote location is not the 5-volt level TTL, but a large voltage of -12 volts to +12 volts, so communication is possible even if there is a slight voltage drop between the communication lines. Therefore, in order to have a sufficient communication distance, it is a system that greatly amplifies the TTL level signal and communicates upward, and uses 3 lines, TX, RX, and ground. And only point-to-point, that is, one-to-one communication, is possible. RS-232 is a communication standard that allows communication up to 15 meters and requires 3 lines, but in actual industrial sites, communication over longer distances is often necessary. So what should we do? In order to establish long-distance communication, the problem of external noise that will inevitably occur in long communication sections and the problem of voltage drop due to line resistance must be solved. To solve these problems, differential signaling, that is, communication using differential signals, must be used, and the long-distance communication method that adopts this signaling method is RS-485. Differential signaling is a method of converting one signal into a positive signal and a negative signal and sending it on 2 communication lines at the same time. And the receiving side receives a subtraction signal of the 2 signals, that is, a signal that has been processed by subtracting the positive signal into a negative signal. The received difference signal can secure a potential difference of several volts or more. And since noise introduced from the outside enters the plus side and minus side lines at the same size at the same time, the subtraction signal received on the receiving side has the effect of eliminating noise, so it has considerable immunity to external noise. If a 0 to 5 volt signal is transmitted on the plus communication line and an inverted 0 to minus 5 volt signal is transmitted on the minus communication line, the subtraction signal on the receiving side will secure a potential difference of 10 volts, and at the same time, the noise introduced to the 2 lines is eliminated. Therefore, the structure is to convert the TTL signal from the MCU into inverted and non-inverted signals with a 485 transceiver IC such as MAX 485 and transmit them through 2 communication lines A and B. By adopting this differential signal transmission and reception method, a communication distance of up to 1.2 kilometers can be secured. The right side shows the internal structure of the MAX 232 IC and the MAX 485 IC. The MAX 232 converts the small TTL level transmit-receive signal on the left into a greatly amplified level signal as shown on the right. And the MAX 485 converts the small TTL level signal on the left into a greatly amplified signal by non-inverting A and inverting B. In order to selectively transmit and receive data through the A and B lines, the MAX 485 IC requires the RE terminals, which are receiver-enable, and the DE terminals, which are drive-enable. It shows the communication line connection structure of RS-232 and RS-485. RS-232 should be structured so that the transmitting side TX of MCU1 is connected to the RX of MCU2 via MAX232, just like the UART wiring structure. And the receiving side RX of MCU1 should be connected to the TX of MCU2 via MAX232. There are many connection errors in this part, so it is important to check the sending and receiving terminals between the 2 MCUs. The wiring structure of RS-485 is that the 485 transceiver MAX 485 is connected to the TX and RX of each MCU. And the 485 communication lines that are interconnected between MAX 485 are A and B, which must be connected to the same pins. A is a non-inverting signal line and B is an inverting signal line. Since transmission and reception cannot be done simultaneously on these 2 differential lines, the RE pins and DE pins must be tied together so that the transmission and reception enable can be switched at the TRX control pin of each MCU. In other words, RS-485 adopts a half-duplex structure transmission method that selectively transmits and receives with a single line. This time, we will look at the waveforms and signal levels on the communication lines of UART, RS-232, and RS-485. UART communication is a method of communicating using TTL or CMOS level signals, that is, general signal levels of 0 to 5 volts, and this single signal structure is called a single-ended signal. RS-232 communication is a structure that communicates by sending and receiving signals with a low amplitude range of 0 to 5 volts, and a large voltage swing of plus or minus 12 volts, that is, a large amplitude, between communication lines. By sending signals with such a high potential difference level, long-distance communication is possible without major problems even if the communication line is rather long. The MAX232 IC plays the role of greatly amplifying the TTL level signal in this way. RS-485 communication is a method of sending a signal in differential format, which is formed by converting a low amplitude range signal of 0 to 5 volts into a non-inverting amplified signal on the A line and an inverting amplified signal on the B line. To each communication line, A and B, since this differential signaling communication uses the difference signal between A and B on the receiving side, the noise component is removed from the difference signal for external noise, so it has strong noise immunity and also has a significant advantage in long-distance communication. Due to these advantages, differential signaling communication is adopted in USB, Ethernet, HDMI, PCI, SATA, etc. In the method of processing transmission signals within a communication line, we will look at single-ended and differential signaling. Single-ended is the most common signal transmission method that communicates by swinging the voltage from 0 to 5 volts or more on a single line. If external noise enters the signal line, the noise signal directly affects the receiving end, which can cause malfunction or data errors. Therefore, long-distance communication is not possible, and only communication within the PCB board or short-distance communication with a short cable is possible. UART and RS-232 communications fall into this category, and additional measures such as shielding the outside of the communication data line are required to reduce the influence of this noise. On the other hand, differential signaling is a method of sending a non-inverted signal and an inverted signal on two adjacent lines, and by using the subtraction signal of the two signals at the receiver, it has the characteristic of naturally removing external noise. And by using the subtraction signal, even if the communication line is long and the amplitude drops somewhat due to signal attenuation, the final signal at a level that can be processed to some extent can be obtained. So it can be applied even to considerably long communication lines. In the case of RS-485, communication is possible up to 1.5 kilometers, and it can be applied to high-speed communications such as Ethernet, USB, and HDMI that require very high-speed communication. Here, it should be noted that as the communication speed increases, the effective communication distance becomes shorter. High-speed communication can be affected by line resistance and parasitic capacitance, and is also sensitive to noise, so the coverable communication distance cannot be helped but be short. The communication distances presented as standards, 15 meters for RS-232 and 1.2 kilometers for RS-485. Are based on the effective transmission distance based on a communication speed of approximately 9,600 bps. Let's organize the representative serial communications, RS-232, RS-422, and RS-485, through a comparison table. The signaling method is single-ended for RS-232, differential for RS-422 and RS-485. Here, RS-422 is integrated with or has compatibility with RS-485, so it is mostly applied as RS-485. The transmitting and receiving devices are RS-232, which is a one-to-one, point-to-point method, RS-422, which is a 1-to-10 multi-drop, and RS-485, which can network up to 32 masters and slaves. In other words, RS-422 and RS-485 can be configured to connect multiple devices by applying the bus method in addition to expanding the communication distance. The transmission method is full duplex, as RS-232 and RS-422 have separate communication lines for TX and RX respectively, allowing simultaneous transmission and reception. While RS-422 has 4 communication lines, 2 differential lines for TX and 2 differential lines for RX, and RS-485 can be configured as a network with a 2-line method, half duplex, and a 4-line method, full duplex, depending on the transceiver IC. In other words, RS-485 ICs are separately lined up for half duplex and full duplex, so they can be applied according to the purpose. The maximum communication range is 15 meters for RS-232 and 1.2 kilometers for RS-422 and RS-485 at 9,600 bps. The maximum transmission speed is 20 km bps for RS-232 and 10 megabits per second for RS-422 and RS-485 at 12 meters. As mentioned earlier, the communication speed and effective transmission range are inversely proportional. The receiver input sensitivity, or the minimum recognizable voltage level, is plus or minus 3 volts for RS-232 and plus or minus 200 millivolts for RS-422 and RS-485. This means that RS-232 does not recognize signals within plus or minus 3 volts, and RS-485 does not recognize signals within plus or minus 200 millivolts. For other input-output voltage ranges, please refer to the reference.